Hello and welcome back to the channel. So today in this video we are going to discuss yet another concept regarding set theory. This concept is called operation on sets. So what are the basic operations that can be performed on sets? There are three basic operations that can be performed on sets. These operations are union of sets, intersection of sets, and difference of sets. So in this very video we are going to discuss union of sets and properties of union of sets. So let's start. So what is union of sets? The union of any two sets results in the formation of completely new set that contains all those elements that are present in one of the two sets, including those which are present in both. The union of sets is represented by using the word or, and the set notation to represent the union of sets is somewhat like U in caps. So union of sets is nothing but the combination of two sets in such a way that this combination results in the formation of a new set containing elements which might be the elements of both the sets or one of the two sets. So now suppose we have an element x. So this element x can either be an element of A or it can be element of set B. Let's try to understand this very concept using two sets. So take for example, we have set A containing elements 1, 2 and 3. And we have set B which contains elements 3 and 4. So what will be the union of these two sets? So A union B will be a set having elements 1, 2, 3 and 4. So here you can see that each one of the elements is either an element of set A or an element of set B or both. Take for example this element 2. You can see that this element 2 belongs to set A. Similarly, if we take this element 4, we can see that this element belongs to set B. Now if we take this element 3, we'll see that it belongs to both A as well as B. Here you can see 3 is an element of set A as well as of set B. So this is rather an easier concept to understand. Now let's try to understand this concept using a Venn diagram. So here again we can see that we have two sets A and B, and these two circular regions, this circular region represents the elements of set A and this circular region represents the elements of set B, and this whole region, this whole portion represents A union B. Here you can again see that this region has elements that of set A as well as that of set B, and it has those elements too which are elements of set A as well as set B. So this very Venn diagram represents A union B. So what are the properties? The first property is called commutative property, which states that A union B is equal to B union A. So to understand this property, let us take an example of set A having elements 1, 2, 3 and 4, and another set B having elements as 3, 4 and 5. So now let's see what will be A union B. A union B will be having elements as 1, 2, 3, 4 and 5. So here A union B is a set having elements of A as well as B, or elements which are in both. So now let's try to calculate B union A. So this set will be having elements 3, 4, 5, 1, 2. So here you can see that the order, as we know, doesn't matter in case of sets. So we can say that A union B is same as B union A. So next property is called associative property. So here we'll talk about the grouping. So here we are having A union B union C is same as A union B union C. So here the grouping doesn't matter, which means that A union B union C will give us the same result as A union B union C. So here again we can consider three sets. We have set A having elements 1, 2. We have set B having elements 2, 3. And we have set C having elements 3, 4. Now let's see what A union B is. This will be having elements 1, 2, 3. Similarly, we can calculate A union B union C. So this A union B, we have to calculate its union with set C. So that will be having elements as 1, 2, 3 and 4. Now let's see what will be B union C. So B union C will be having elements as 2, 3 and 4. Now let's try to find out the union of set A with B union C. So that means A union B union C is equal to 1, 2, 3 and 4. So here again you can see A union B union C is same as A union B union C. So this is how this property works. Now here again we have another property called idempotent property. This property states that A union A is A, which means that determining the union of a set with itself, the result will be the same set. So suppose if we have set A having elements 1, 2 and 3. So we have another set which is having same elements 1, 2 and 3. So what will be A union A? As we know that repetition is not allowed in sets, so A union A will be 1, 2 and 3, which is same as set A. Another property is called property of phi or identity law. This property states that A union phi is equal to A. As we know, phi is an empty set, so determining union of an empty set with a given set will result in the same set. So obviously, if we have set A having elements 1, 2 and we have an empty set, the union of these two sets will be obviously set A. Now let's move to final property, which is property of universal set. Here you can see that A union universal set will give us a universal set as result. So suppose we have a set A having elements 1, 2. We have a set B having elements 3, 4 and we have a universal set having elements 1, 2, 3, 4, 5, 6, 7, 8. So what will be A union universal set? That will be equal to 1, 2, 3, 4, 5, 6, 7 and 8. So we are trying to find out the union of set A with universal set, and this, as you can see, that this whole set, the union of the given set with a universal set, gives the result as universal set. I hope this makes sense. Do subscribe to the channel and thanks for watching.